Over the years, we've talked a lot about dark matter, and you can't blame us. Even though it exerts gravitational effects, this stuff is invisible in telescopes, and it's found all over the universe, but scientists aren't totally positive what it is. Dark matter is one of the coolest mysteries in astronomy, but it's also made many of you raise your eyebrows. Whenever we bring up dark matter, commenters ask why scientists are so stubbornly positive it exists. Like, why can't they just admit they're wrong about gravity? The truth is, though, scientists have spent decades trying to alter gravitational laws to explain dark matter without dark matter. And while they have had plenty of successes, a recent paper says they're really likely to be wrong. Like this likely to be wrong. That's a lot of nines. Lots of independent evidence points astronomers toward dark matter. The most famous comes from stars and galaxies. Some of them move too quickly, to the point that the gravity from visible matter can't be the only thing holding them together. Computer simulations of the universe's evolution also require dark matter to produce realistic results. And the cosmic microwave background, temperature variations imprinted on the universe by the Big Bang, has patterns we can't make sense of without a bunch of the stuff. Specifically, we need about 5 times more dark matter than regular matter, which is the same amount we infer from those other methods. So it's not like astronomers have been chomping at the bit to postulate what this matter is. They've been forced to their current ideas by almost a century of measurements. Even if we keep failing to discover what exactly dark matter is, the case that it's there seems pretty solid. Then again, to make dark matter work, we do have to make some pretty extraordinary claims. Like, we have to conclude that there's 5 times more invisible stuff out there than what we can see. So, some researchers haven't given up on searching for alternate explanations. One of the most famous is an astrophysicist named Mordechai Milgram. In the 1980s, he wondered just how much you would have to change our ideas about gravity to explain galaxies' behavior without dark matter. To figure it out, he invented the field of modified Newtonian dynamics, or MOND, and it's been growing since his initial papers. Currently, gravity is explained by Einstein's space-time warping general theory of relativity. Among many other things, it shows that gravity gets continuously and smoothly weaker as you get farther from an object. MOND is a little different. This method tweaks general relativity's mathematical approach to gravity. Near something massive, its predictions are pretty similar, but they're different as you get farther from something. Instead of gravity getting continuously weaker, MOND usually has what's called a fundamental acceleration scale. It's a sort of lingering gravitational effect where you wouldn't really expect one using general relativity. So far, this new method seems like it can explain a lot. Many galaxies' motions fit MOND's predictions just as well as dark matter's, and simulations with MOND have even had success reproducing the universe's large-scale structure. But the method still has plenty of problems. For example, it has trouble recreating those patterns in the cosmic microwave background, and it can't really account for all the different ways we see galaxies behave. Some galaxies act like they have almost no dark matter in them, while others might be 90% dark matter or more. And MOND has trouble reproducing that variety. MOND also has issues with objects like the Bullet Cluster, an object some 3.7 billion light-years away. There, gravitational effects seem to be completely separated from visible matter, as if there's dark matter in one place and matter in another. Some people would argue that general relativity and dark matter have had a decades-long head start, and that researchers will work out the kinks in MOND eventually. But others aren't so confident. Earlier this year, a team of astronomers searched for the fundamental acceleration scale by looking at the rotation rates of almost 200 galaxies, and they found that MOND doesn't fit the data. No matter which specific model you're using, MOND would predict the fundamental acceleration scale should be the same throughout the universe. But this team found that different galaxies required a different scale, which kind of throws a wrench in things. Of course, nothing in science is 100% certain, but the team's analysis says that the chance that MOND is still right is pretty slim, like about 1 in 100 billion trillion, a number with 23 zeros in it. Some scientists have disputed that extreme statement, saying there's far more uncertainty than the new paper claims. But possible is awfully far from 1 in 100 billion trillion. Now, this all might have been the death of Mond once and for all, if another paper hadn't come out a few weeks later. In it, a different group studied almost all of the exact same galaxies, but they analyzed the data in a slightly different way. And they found clear evidence of a fundamental acceleration scale that worked for all of them. It's not obvious what caused this difference, but it does mean that Mond isn't dead yet. At least for now, though, the majority of astronomers and cosmologists do think dark matter is still the right approach, and they have decades of good evidence to support that. After all, on scales bigger than individual galaxies, Mond repeatedly fails, while dark matter repeatedly succeeds. Researchers will keep looking into alternative explanations, but at least for now, no other idea is anywhere near as successful as dark matter is. So we'll just have to keep looking. Thanks for watching this episode of SciShow Space, and thanks to all the commenters who asked questions and inspired this episode. If you have a pressing space question or fact you think is really cool, go ahead and leave it in the comments. We'll do our best to check them all out. If you want to make sure we see your question, though, you can go to patreon.com/scishow.